Hello, welcome back to my channel. In the last session we have seen about the potential due to a point charge. We have got the equation as V is equal to Q by 4 pi epsilon naught into R. So now we will see potential due to a dipole. Same in the previous chapter we have seen electric field due to a point charge as well as due to a dipole. So now here we have already seen the potential due to a point charge, and now we will see potential due to a dipole, so that we can compare the equations of electric field and the potential and how it varies with the distance or R. So now potential due to a dipole. Important derivation. First, what is a dipole? It is a system of charges, equal and opposite charges, separated by a distance of 2a. So I will take charges. Let this be minus q, this as plus q, which is separated by a distance of 2a. Total it is 2a. Let me consider this as the origin O, so that this is A and this is A, equally distributed. To find out the potential at this point P. Point P, okay, say that this is at the position vector R, here and from here, due to both the charges. Now we have seen that electric field obeys the superposition principle. So in the same way, what is potential? Potential is work done per unit charge. So work done, we have work done here in the equation. So in the same way, this potential also obeys superposition principle. That is why the total potential due to a dipole will be the sum of the potentials due to plus q as well as due to minus q, V. So when we write the equation, I will just write down it later. Let me complete this diagram. Let me take this as point A, this as point B, and say that this is at a distance of R2 and R1. No, I will write this as R1 and this as R2. So from the origin R, from the plus q distance of R1 to the point P, from point A or minus q at a distance of R2 to the point P. Now I want the potential at this point due to the dipole, this dipole, which is separated by a distance of 2a. This is the origin. So this is A, this is A. Let this be angle theta. This is angle theta, because we have already seen electric field due to a dipole not only depends on R, but also it depends on the angle between or made by the dipole with the point where we are considering. So we have to consider angle theta. Okay, and also one more thing is R we consider, which is much greater than the A. This distance is very much greater than A. Okay, so these are some of the assumptions that we make. Only two assumptions. So theta and R we have to consider. R as much greater than A. So now what will be the total potential? So total potential. So here onwards I will start with the derivation. V is equal to 1 by 4 pi epsilon naught into Q divided by plus Q divided by PB. My plus, it is minus here, so I will write minus as a whole. So minus q divided by PA. Minus q divided by PA. So it is V is equal to q we can take outside, q by 4 pi epsilon naught into 1 by PB is nothing but R1 minus 1 by R2. Now we have to write this R1 and R2 in terms of R. so that we can simplify it further in terms of angle, and then we can write in terms of dipole moment. What is dipole moment? It is directed from, it is a product of one of the charges and the separation between the two charges. So it is directed like this. So we usually write it like this, P, correct? So now just keep in mind that P is in this direction. Minus Q2 plus Q. Now let us find out this value R1 and R2. R1 and R2. How to find out this R1 and R2 in terms of R? What we do is, you just extend this one and make it right angled triangle like this. Okay. So that this will also be theta. Let me mark this as point M. This extra part is not there in the textbook. They have directly substituted the values. Okay. So now what is this distance AO? AO is nothing but A. OB is nothing but A. So total distance is 2A. So now theta. I want, see, from here to here it is a straight line. So that in order to write in terms of R, it is total this distance PO plus OM. Correct? Now we have to find out this OM value. What will be OM? If you consider this triangle MAO, we have to consider cos theta. It is simple. Cos theta. What is cos theta from this triangle? Adjacent by hypotenuse. OM by OA. So OM will be equal to OA. OA is nothing but A. So A cos theta. So OM will be equal to A cos theta. Therefore, now R becomes, R1 becomes how much? R1 will be equal to R plus this OM. So R plus A cos theta will give you R1 in terms of R. R plus A cos theta. Let me write it here. So OM we have got. Therefore R1 is equal to R plus OM, which is equal to R plus A cos theta. Similarly, what will be R2 in terms of R? R2, sorry, this is R2. This is R2. What will be R1 in terms of R? R2. R2 is R plus OM. So R1 will be here. Here you have to mark. No need to do that again. So this and this will be same now. So you have to subtract this much. So R1 will be R minus A cos theta. R2 is R plus A cos theta and R1 as R minus A cos theta. Now substitute the values here. But before substituting, you have some calculations further. Okay. So just keep in mind, the required formula is V is equal to 1 by 4 pi epsilon naught Q into 1 by R1 minus 1 by R2. Here is what we have to substitute. And also we have seen that R1 is equal to R minus A cos theta and R2 is equal to R plus A cos theta. Now square this one. Square the two terms, because finally we have to substitute in the binomial theorem and then find out the value of 1 by R1. So square the terms. You have R1 square is equal to R minus A cos theta whole square. So it is R square plus A square cos square theta minus 2AR cos theta. A is very small, theta is very small, so cos square theta can be neglected. So you have R square plus a square minus 2ar cos theta. This is for r1 square. Now take out r outside. R into r square outside. 1 plus a square by r square minus 2a by r cos theta. A square by r square can be neglected because r is very much greater than a, so that their ratio becomes very small. So you have r square, r1 square is equal to r square into 1 minus 2a by r cos theta. Now take out the reciprocal. It is 1 by r1 square is equal to 1 by r square into 1 minus 2a by r cos theta to the power of minus 1. Reciprocal. So 1 by, instead of writing 1 by the whole term, I have written like this, to the power of minus 1. Okay. So once you know this test, it is simple. So let me erase this again. All these steps to show the simplification part. So we have 1 by r1. I will take the square root now. From here I will take the square root. 1 by r1 is equal to 1 by r into 1 minus 2a by r cos theta to the power of minus half. Correct? Now apply the binomial theorem. Not for higher powers, only up to degree 2 is enough. So it is r1 is equal to 1 by r into 1 minus of minus plus binomial theorem which you study in maths, a by r cos theta. Okay. Similarly, when you apply for r2, here you will get minus, because here it will be plus. Same concept you have to use. Instead of r1 you have r2, and r2 is what? r plus a cos theta. This much is extra, so it is plus. That is why you get here plus, but here you will be getting minus sign. Same steps you have to follow for that also. So 1 by r2 you will get it as 1 by r into 1 by a by r, 1 minus a by r cos theta. So now 1 by r1, 1 by r2 value directly we have got. Substitute these values in the main equation of potential, electric potential, where we have used superposition principle. So now let me erase this diagram so that I have space to show the calculation. Therefore, in this equation only we will substitute. So V is equal to Q by 4 pi epsilon naught into, what is 1 by r1? This value, 1 by r into 1 plus a by r cos theta minus 1 by r into 1 minus a by r cos theta. Simplified further, 1 by r can be taken outside. So Q by 4 pi epsilon naught into 1 by r into 1 plus a by r cos theta minus 1 minus of minus becomes plus a by r cos theta. 1 and 1 will be cancelled. So you have a by r cos theta plus a by r cos theta. It is 2a by r cos theta. (2a by r) is 2aq. What we can write this 2aq as dipole moment P. we can write it as dipole moment P. So now the equation becomes P divided by V is equal to P dot cos theta divided by 4 pi epsilon naught into r square. P cos theta divided by 4 pi epsilon naught into r square. So now 2aq as P cos theta divided by 4 pi epsilon naught into r square. See that the potential varies as r square, inverse of r square. Inverse of r square. Now this P cos theta we can write it as P dot r. P cos theta can be written as vector P dot r cap. P dots, just for a simplification, if you write this much is also correct. So vector P dot r cap divided by 4 pi epsilon naught into r square. So see that potential varies inversely as r square. And now, so this theta, if it is along the axial line, so theta can be 0 or 180 degree. If it is 0, you just have P by 4 pi epsilon naught into r square. If it is 180 degree, that is along the equatorial line downwards, it is minus P divided by 4 pi epsilon naught into r square. Why minus? Because cos 180, minus 1. But if it is along the equatorial line, or if it is theta is 90 degree, cos 90 is 0. So you have potential as 0. So just compare the potential, electric potential with the electric field, and then remember the equations, how it is varying. You can write 2 columns for point charge as well as for the dipole. You can write the 2 equations. So now when you see that it is not varying as 1 by r, it is varying as 1 by r square. And also the value of potential depends on the angle also. Angle is very important, angle from the dipole, what angle it is making. So angle is also very important. So if you consider that angle, then you get the cone shaped. All these are the higher concepts. So if you consider this point, dipole, and at this point, so at a distance, same distance, then it will make a cone shaped thing, the potential varying. So this is the equation for the electric potential. Vector P dot r cap divided by 4 pi epsilon naught into r square. So for theta as 0 or 180 degree, you can write it as plus or minus P divided by 4 pi epsilon naught into r square. So I hope this is clear, very important derivation. So follow the steps clearly, write the equations for R1 and R2, then take the reciprocal, use the binomial theorem or binomial principle, substitute back in the main equation using superposition principle, and then simplify the concept. So in the coming classes we will see for the electric potential for multiple charges, then we will go with the capacitors concepts. Potential for system of charges we have, and relation between field and potential, that is very important for 2 marks. What are equipotential surfaces, and then potential due to a system of charges, as I have told. So all those concepts we will be seeing. Potential energy in an external electric field, what happens in that case. Now we have considered the dipole and the point charge. So next we will see about the system of charges and other relations. Thank you.